So most groups on the right track here. I'll look at it first by rows. If I pay attention to this row with the red and the blue polynomial, they're different in that the red polynomial has opposite end behaviors and the blue polynomial has same end behaviors, so they don't share anything about their degree in common, so it must be something about their leading coefficient. Well, remember, the leading coefficient tells you about the right side of the graph. Both of these right sides of the graph are rising. So I would label over here that this one has a positive leading coefficient. And then, of course, if I look down at the next row, these are both polynomials with a negative leading coefficient because the right side is falling. Okay. In the columns, we're going to see, okay, now the red and the green polynomial have opposite end behaviors, right? Rise, fall, and the first one from right to left, and then it goes fall, rise. So this means it has an odd degree, and then, of course, we have same end behavior, so we must have even degree here. Okay. So remember I talked about yesterday, imagine you or me as a polynomial. When we talk about end behaviors, we're talking about the arms of the polynomial, what happens on the far edges of the graph. So my arms can both go up, both go down. My right side can go up, my left side can go down, or my right side can go down, my left side can go up. Those are like the four possibilities. What's going to change from polynomial to polynomial is the jazz in the middle, right? Like how many times does it turn? Is it crossing the x-axis? Those things are going to be dependent on the polynomial function itself, and we'll learn more about those. Okay. So today we're going to continue on 4.1, and I'm sorry that everything, I thought I fixed my projector, but I didn't. So we're going to talk about graphs and polynomials. Probably easier to see our graphs with the lights off. They didn't, the projector isn't very bright. Okay, so this first part that we're going to go through is like actually you're still just looking at a graph. You're not creating the graph, but the second part of the notes you're going to actually tonight draw graphs. Now, your graphs for the polynomials aren't going to be like perfect graphs of polynomials. They're going to be as good as you can get it based on what you know. But we will continue to learn more about polynomials and add more detail to our graphs as we go through the chapter. So here's a question about a function. So, you know, like looking at that function, what do you think about that function? Does it look familiar? It looks like a parabola. I'm guessing it's quadratic, but technically it could be any even degree function, because even though like a fourth degree could have 3 max turns, that means it's the maximum number of turns. It really could only turn once. So it could be a fourth degree, but it's looking like a quadratic to me. Okay. So I'm asking 4 different questions over here on the side. Okay. If this is my graph of f of x, and I'll draw it a little darker so you can see it a little easier. And if you want to plot like the specific points that go along with it, this x-intercept is at 1, 0. This x-intercept is at 3, 0 if you want to label them. And it looks like your vertex or your turning point is at 2, negative 1. When you do these problems in the textbook, you'll have a grid that you can see pretty easily where those points values are. Okay, so I want to know when the function f of x is increasing, decreasing, greater than 0, and less than 0. And probably the hardest part about that is just like making sure you understand what the question is. So can you take your pen or pencil or your finger and just trace your graph from left to right? Will you do that? I know it seems silly. Just put it on the left side of your graph and trace your graph from left to right. Okay, and do it a couple times. Do you know when you're increasing and decreasing? Yeah. At the beginning, I am decreasing, and then at the vertex or that turning point, I start increasing. So I'm going to go ahead and label those. I'm decreasing here, and I'm increasing here. If you're somebody who you know, like you feel like learning, maybe like if you can do something or you're moving around or something like that, even just following the graph with your finger can be really helpful. So like your finger is going down, this is decreasing. Now my finger is going up, that is increasing. Okay. So where's the place where it changes? At the vertex, or like I called it the turning point, let's say it's not a parabola, okay? But yeah, it's turning right there. So I think about it like this. Like this is the line x equals 2, right? Whether it's a line of symmetry or not, it's cutting up the graph. There's a left side and there's a right side. And on the left side, my graph is decreasing, and on the right side, my graph is increasing. So to say when is the graph increasing, well, that happens whenever x is less than 2, to the left of 2. Okay, so I'm going to say x is less than 2. And that just really means to the left of x equals 2. It's decreasing. Oh, shame on me. That's the decreasing part, isn't it? I'll just move these down over here. My apologies. Okay. So it's decreasing left of 2, and then on the right side of 2, it's increasing. So I can write that as x greater than 2. And if you want to like, what does that mean? It means right of x equals 2. So this vertical line is like splitting up my graph into two sides. The side where it decreases and the side where it increases. The most common mistake that people make is they use y values instead of x's. But we want to say it's doing it on the left or it's doing it on the right. So we want them described by y's. Okay, now I have two more questions I'm asking. F of x greater than 0, f of x less than 0. All right, what does that mean? Someone said it? Why? F of x is just a fancy way to write y, isn't it? So we could rewrite these for ourselves. Another way to say this is to say y is greater than 0. Or we could say that y is less than 0. Well, what kind of y's are greater than 0? Positive y's, Jacob says. And positive y's in this picture, I'm going to erase everything for right now. I'm going to erase all my stuff. Positive y's in this picture, because it gets a little messy otherwise. Positive y's in the picture happen when y is above the x-axis, right? These are all the positive y's because I go up, and if my y is negative, I go down. So positive y's, or you might be thinking above the x-axis. So like, when is y greater than 0? Really at two places, isn't it? Y is greater than 0 over here on the left, and y is greater than 0 over here on the right. So in order to answer the question, when is f of x greater than 0, I have to give two intervals. Okay. How would you describe this green portion on the left? It's all the x's that are less than 1, right? So again, we're like breaking up our graph using vertical lines. And these are now not the vertical lines going through like that vertex or the turning point, but they're the vertical lines going through the x-intercepts. Because on the left side of that, it's above the x-axis, and on the right side of it is below the x-axis. So we would say, when is it positive for all x is less than 1, and all x's greater than 3. So on the right side of 3. So where is y negative? Less than 0. In the little in between, right? Now, if it's in between, you're allowed to write a compound inequality because all the numbers that are in this range are greater than 1, but at the same time they're less than 3. So you can write that, I always call it like a sandwich. Put x in the middle. And you got the low bound of 1 and the high bound of 3. Okay. You can't write those two green ones as any kind of like compound inequality. So don't try putting x in the middle with a less than 1 and a greater than 3 on the other side. Ew, I'm going to take off for that. That's not a thing. Because you can't be less than 1 and greater than 3 at the same time. There are no numbers like that. But if you've got numbers that are sandwiched in between a low bound and a high bound, you can do that. Okay, questions, concerns about those? I will say this, it's a little bit tricky looking at the screen and like being like, where did she get 2 or where did she get 1 or 3? So what I want you to focus on when you get to these problems on the homework is like, put your finger on the paper and move from left to right. You will then be able to tell when your finger is decreasing and when your finger is increasing. And you need to like find that x point where it changes. Okay? And then for y is greater than 0 and y is less than 0, you guys would know that means like positive above the x-axis, negative below the y-axis. So those are going to be x-intercepts that you're interested in instead of turning points. Okay, last example that I want to do is a graphing problem. If I can get it to go to next slide. Okay, so here are like the basic 4 steps right now to graphing. We're going to add to this as we go through the chapter and we learn about other parts of the polynomials. Okay, but for right now, you're going to be graphing using ordered pairs, so like a table of values. I say 5 to 6 points should probably be enough for you. If you're still really confused, you can pick more points. Okay. You might want a calculator for this part. Okay, that's okay. Of course, I always include the y-intercept because that's easy. Yesterday we said the y-intercept is the constant, right? So like just looking at my equation that I'm going to graph here in a little bit, the y-intercept happens at 2, up 2 on the y-axis. 3 is end behavior. Okay, so when you graph for me on quizzes and tests, I want to see a picture of a graph that has correct end behavior. Like if it has a positive leading coefficient, your right side should be rising. If it has an even degree, the left side should also be rising. So I want to see that the arms of your polynomials are pointing in the right direction. Okay. The 5 to 6 points should help you with like what's happening in the middle of the end behaviors. Okay. And then of course the ends of your graph are just going to either be going up or down. Okay, and then 4 is a final one just because sometimes we can feel like, okay, I have freedom now, just like draw whatever kind of crazy polynomial I want in the middle. You know, most of our polynomials are like quadratic to or quintic, maybe like a 5th degree polynomial. So I shouldn't really, unless I'm giving you like a 8th degree polynomial, I shouldn't see something with like 7 turns, okay? So you want to like keep a handle on things, and you don't want to get too crazy and draw all these turns and x-intercepts if it's a cubic polynomial and it can only cross the axis 3 times. So like you want to keep that in the back of the mind, but that's not really like really absolutely important to your graph. It's just like at the end, make sure you didn't go too wild with your turns. Okay. So I'm going to do this example. F of x equals x cubed plus x squared minus 4x plus 2. Okay, well, my first step was to, find a list of points that I could plot. And one of the points that I'm definitely going to put on there is going to be my y-intercept. Think about putting numbers into the polynomials. You got to cube them, square them. Sometimes you got to raise them to the fourth. If you're doing this in your head, you probably want to pick smaller x values, right? Because they're easier to cube. Already 3 cubed is what value? 3 cubed is 27. 3 squared is 9 times another 3 makes it 27. So like, wow, that's already pretty big, right? So I'd probably pick some positives. So I'd pick 1 and 2, and I'd pick some negatives. Now, if you're not convinced about what your graph should be doing, you could always pick like more numbers or numbers that were further away. Okay, so now I just have to plug them in. I'm going to do this part pretty fast like I'm a calculator. Okay, so I'm just taking the 2 and I'm plugging it in for all the x's, right? So if I did f of 2, that's 8 plus 4 minus 8 plus 2, so that's 6. If I did f of 1, that's 1 plus 1 minus 4 plus 2, so that's 0. If I did f of negative 1, if you're going to put negative 1 in your calculator, you should protect it with parentheses, because otherwise your calculator will make this part negative when really negative 1 times itself is positive 1, so you need to protect the negatives with parentheses. But this one will be negative 1 plus 1 plus 4 plus 2, so that's what, 6 again. And then f of negative 2 is negative 8 plus 4 plus 8 plus 2, so that's another 6. Okay. So then, those are the points that I can plot. Negative 2, 6. Negative 1, 6, 0, 2, 1, 0, 1, 6. Okay, and you don't just want to play like a strict game of connect the dots. Okay, like these are not going to be like a horizontal line in there. You must have like some kind of like curve where I like turned around at some point. To help you decide like where to start and end your curve and things like that, consider your end behaviors. Okay. Based on my polynomial function, my leading coefficient is positive 1, so my right side should rise. My degree is odd, so my left side should fall. And that kind of helps me out. Like after this 0.26, I just want that side to rise. So then I must be coming down. I'm going to turn right there at that x-intercept. I don't know really what happens, but I'm going to turn right there. Because I got to come back up through my y-intercept, and then I got to cross this point, and at some point I have to turn back around so that I can get through this other one. Remember, they're not just going to connect straight across. A polynomial is not straight, it's curvy. Okay? And then this side, I've already done 2 turns, and it's cubic, so that's the max turns it can have. This side must fall. Just drop. So like what I don't know is like how high did this go? I don't know. Like maybe it really did cross the x-axis and it came back up. We don't know. So like it's not a perfect graph, but it's got the right like end behaviors, it's got the y-intercept, it's got a few points. So we have an idea of what the polynomial will look like. Okay? So if you look at your gold sheet, those are the steps that I am asking you to do for graphing. Is pick some points. You can use a calculator, you can do like I did, just evaluate. Of course, use your y-intercept because that's an easy one to get. And then consider your end behaviors to help you connect the points. Your brain kind of has to fill in the blanks, and that sometimes can feel weird. Okay, but you fill in the blanks what that picture might look like. And remember, I didn't get too crazy right here. I didn't start turning it all the way around because I'd already made 2 turns. So that was the max turns I could have. Any questions?